Hello, everyone. Welcome to our webinar session today. Today, I'm going to present a topic on continuous replication from Oracle to MongoDB or Atlas. First, a little bit introduction of myself and TapData. My name is TJ Town, and I am the founder of TapData. Before I founded this company, I was working at MongoDB as a principal solution architect. I worked there for 6 years, and that's actually one of the, over the years, I found something that we needed something really to help to solving the data problems for the industry. And that's why I founded TapData. And I was a very passionate MongoDB programmer and architect. And I also founded a Chinese MongoDB community. At the peak time, we had like more than 50,000 members. TaDdata is a company, startup-based company based in Hong Kong. And our motto is connecting the legacy with modern, really helping enterprise to make best use of their data. We are a Google Startup Accelerator member, and we have secured more than $10 million VC funding. Currently, we have a team size of around 42 engineers, and including 9 certified MongoDB professional, 1 MongoDB master, and 1 MongoDB champion. All right. So today I'm going to talk about the continuous replication to MongoDB, and I'll divide it into a few sections. First is why we want to do that. And the second, we will touch on a couple of common approaches and the limitations or pros and cons. And then we will discuss our solution, TapData, how TapData does it. And we will provide you about 10 minutes or so video demo. And then that's about it. Let's get started. So before we talk about replicating to Mongo, maybe just a quick note on why MongoDB first of all. So MongoDB is probably the most successful modern database today. If you think about most of the really popular databases like Oracle, DB2, Sybase, and Postgres, SQL Server, etc., they were all started up in 90s or even 80s. Over the last 2 decades, really, there are lots of new databases, tons of them. But MongoDB is probably one of the most popular one. And just looking at the numbers, like they have 47 customers. And even today, and the community version, they have like 140,000 developers joining a MongoDB community every month. And myself, being a convert from a relational database world, like more than 10 years ago, I was attracted by really the flexible document model. And document model is very easy to use and very allows you to write very little code to interact with database, really allows developers to focus on the coding part, program logic, rather than worry about databases. To me, it is really the most important thing that keep the developers around the MongoDB. Of course, in the early days, especially, MongoDB is one of the very early first solutions providing scalable sharding architecture, allow you to really scale a large amount of data and the traffic, and to still provide a high performance. That's also a very important reason it becomes very popular today. But anyway, today, I think MongoDB is already being in business for more than 15, 16 years. It's a very mature product database today. A lot of people are using it. And today we are going to focus on a data replication into MongoDB. So we want to say why we want to do that and why we want to replicate data to MongoDB and why we want to continuous. One of the first use cases is really query acceleration. So the idea is that really speed up the queries to using a modern database to solve the old performance problem that faced by a lot of single architecture databases like Oracle or PG, SQL Server, etc. So this example, I'm going to use a airlines, which is one of the really my customers. When I worked at MongoDB, I worked for. So at that time, one of the top airlines, they were trying to build a new app to allow customers to search their flights more flexibly by dates, by region, by a few number of airports. So really, rather than just searching by the specific dates or starting and departure and arrival, they allow you to search by a total region around this vicinity of the airports. Also a calendar, low-cost calendar. So really, this drives a lot of queries onto the database. At that time, today they are still using Oracle as a primary database for their application and serving their customers. But it was considered that cannot really support up to 100 times more queries, concurrent queries, to drive to the database. So they were looking to solutions to really having queries on a modern database. Now, they are not going to decommission the Oracle-based application anytime soon. So really, we have to figure out a way, how do we to make these flight data or inventory data or tickets data available to be put into the Mongo to allow them to search in a modern database. So that's really comes to the question, how do we move the data over from existing database to a new one? Another use case is, which is also we are working for, we are helping our customer to doing is a regional healthcare company. They are really, what their challenge is, over the years, they have acquired and merged a lot of clinics, managing them up to a few dozens to 100 today. Because the nature of the acquisition, they do not necessarily really merging the operating system or operational applications. They only merge the business. So doing the business under one brand. But behind the scene, they are still using the old legacy applications systems to do the business. So as you can imagine, different clinics, they are using different systems, sometimes built by themselves, sometimes are provided by vendors, and sometimes just off-the-shelf SaaS products. So they have a variety of the clinical management system doing similar things, like making appointments, keeping track of the patient data or the visits, and also patient records, etc. Now, when they try to improve their customer experience, say, we would like to have a unified appointment management. You can booking appointments across all the clinics in our brand. And they realize that's going to be a little difficult because all the data are scattered and locked in each individual system's applications. They are not talking to each other. And if you are doing the traditional batch, like copy the data every night or every other day, that data is not going to be usable because the appointments are changing all the time and during the daytime or real time. So really, we need to figure out a way to consolidate these customer data in one place and having this fresh data to made available to a mobile app. So they were considering using MongoDB Atlas to consolidate these data in one place. But how do we getting this data from Oracle, from MySQL or DB2, and freshly into MongoDB? That's really a big challenge. So that's another use case that we want to say looking to move the data over to MongoDB to support new use cases. In this time is a consolidation use case. So with these two use cases, we can look at some commonalities of the use cases. One is for these cases, customers are not looking to replace or rewrite the existing applications. The current applications are still serving their purposes, and they plan to continue to operate, but they are working on new user cases, and they're utilizing new modern databases platforms like MongoDB Atlas. So the problem is really how do we make the customer data, which is really logically one copy, how can we make those data from legacy application systems to be available to new applications? And we have to make this ongoing all the time until we decided to decommission the current application, which may be a year or 2 years or even 5 years later, or even not even on the plan. We have to have a solution to allow the data to moving and in sync in these two applications. So what are the common approaches really for this problem? And there are really a number of ways, but two of them are very commonly adopted by the enterprises. First is very straightforward, which is adding an API layer to the existing systems to expose the data to new apps. The other one would be using a dual writes method to write data In addition to the current or legacy database, I also write to the new databases. Let's take a look at these two options. The first one is for, let's say, on the left side, we have the current application running on Oracle. Our application is running, still writing to the Oracle database without problem. Now we want to expose these data to the new apps on the right-hand side. So first, we build a new API service using Java or Python, whatever. Typically, Java is very common. It's pretty quick to set up and pretty easy to design and conceptualize and implement it. Then once we have this API component and a new component, we will allow the new application to query directly with the HTTP or RESTful API method. So it's very straightforward to do that. And it's also very common, and it's probably without having to procure or investigate other solutions. You can pretty much do it in-house as long as you have some developers at handy to spend. Some of the considerations, though, to think about is it might have some performance implication to your application database, because this is essentially a new workload on your existing database that has been provisioned, deployed, or fine-tuned to support the current workload. And once this new workload is in, you have to take careful considerations, and sometimes might have query performance, a large query that impacting your existing applications. And also, you may need some longer lead time to really get this solution, because you need some time to design, develop, test, and launch. And also, not to mention the continued monitoring and the maintenance. So these are the side cons you have to think about it. Another popular methods, actually very common, especially is if you are having more than one cases, is using a message bus to really routing the data or events between the systems. And typically Kafka is probably one of the most popular ones for the modern messaging bus. How does it work is typically you would go to your legacy applications, say now, in addition to write data your current database, let's say Oracle, you also put the right inserts, updates into using the Kafka API and putting into the Kafka message queue. This way, your changes are being replicated or distributed to multiple downstream applications. And this solution is very suitable especially for there are a number of consumers who's requiring to access for your data, mission critical data generated from your legacy application. The downside or really the consideration is really that this does require a lot of time to ask you to go back to modify your existing applications, and oftentimes require the application may be out of maintenance for a long time, so it becomes very difficult. Or even if it is feasible, it is significant in terms it does get into your primary mission critical workflow in your current application, because you write in your database, then after commit, then you write to the Kafka, right? And after you write a Kafka, then you return your call to your front end. So it gets into the really critical path. So it does add some potential risk, and not to mention the additional work coding. And the coding actually not only on the for the original application, also you have to write the consumer code to pull the events out of Kafka message queue, then write into, in our case, if we want to put into MongoDB, then you needed to work some logic to put into MongoDB. And along the way, you have to manage all sorts of situations when something is a breaks or network timeout or some intermediate breakout or whatever. So it does add a lot of overhead to managing this kind of complexity. That's a downside of this solution. Now, if we put them together, these are actually very common solutions. They are actually used by a lot of companies or enterprises today. But the downside or cons I already mentioned to you guys that they typically involve some development effort, and also they have performance impact or code intrusion to your existing applications. And also something to worry about is once it's in production, you have to add some monitoring and maintenance and housekeeping capabilities to make sure it doesn't break, or if it does break, it alerts you in time. So are there any other choices? Really, TapData is actually designed to really solve the real-time data integration or data movement between the systems inside an organization. So we are taking a pretty novel approach for really solving the ancient real-time data integration problem. How we do it? So at the bottom represents the current your application systems typically running our databases like Oracle, MySQL, SQL Server, or any relational databases are very popular. Probably 80 or 90% of them are running on these applications, running on these relational databases. So what we provided is a TapData live data platform. Once you deploy, install, or with our cloud version, you just connect and provision it, then we allow you to connect to your existing applications databases without extra coding. Actually, you just need to provide a sort of credentials. Then we will, by monitoring the database logs underlying, we will be able to convert the change events into streams instantly without extra effort. Then with these events, what you can do is the events actually comes with the payload and the full record of each row of the data. And with this data, you can do any optionally filtering them or transform them, or without doing anything, it's okay too. Then what I can do is move to your destination. Let's say you want to send it to Kafka for multiple consumers, or you can put into databases, let's say MongoDB modern databases, or data warehouses for analytics, etc. There's a number of use cases, but the idea is we really allow you guys to customers to instantly to get data from your locked silos databases and moving them into wherever you want. So here, the core really function and component or core capability we allow this to happen is our change data capture based or CDC based data pipeline. And I'll take a couple of minutes to explain how does it work. So on the left side, let's say application is on Oracle. Oracle has a redo log. It's maintained by the Oracle database itself. Every database pretty much has some sort of similar log file used to capture all the changes in a flat file mode, and in order to really for the crash recovery or other purposes. So what we do is monitoring this log, which contains all the incremental changes, inserts, updates, deletes. We will, as soon as it applies to the log file, we monitor it, capture it. Then we will capture it into TapData. We format it, standardize it, become a processable event. And you can apply the transformation optionally or filtering optionally. Then move to your destination. And depends on your situation or target. We use a different target plugin mechanism to apply to different databases or targets. In this case, it would be MongoDB. So with the whole process, when let's say something happens in Oracle, order is placed or status is changed, we will instantly know the change and move it over to the destination of your choice. Typically, the latency in optimal situation is sub-second. Oftentimes, but in reality, probably you get a few seconds near real-time delay. So once the whole near real-time data pipeline is really allow you to have data in your destination within a couple of seconds of the changes happening in your source. So that was the key really mechanism. But in order for that to happen, you really have to have that CDC capability. So TapData comes with really already more than 60 pre-built CDC connectors. So you don't have to do any of these kind of. Most of the usual suspects like Oracle, SQL Server, Postgres, or Sybase DB2, we already have them available. You just turn it on, then instantly you can start capturing the CDC events. And we also support capture events from other databases and even Kafka MQs or even SaaS APIs. So the idea is really we have a turnkey solution to allow you to get the source data from any of your data sources. Now, once you have the data, particularly in relevant to our talk today, is really we are talking about moving data from relational database over to not any regular other destination, but the modern scalable document database, MongoDB or MongoDB Atlas, the cloud version. And the very special thing about MongoDB is it has very unique data model, which is we oftentimes call it denormalized a document model. It is much more complex compared to relational table structure. It can allow sub-document and array embedded arrays. So this one, of course, from presentation perspective, it makes very intuitive for developers to look at it because and that's how we really deal with the real-time world. You're looking at the object type of data model, right? A customer has a lot of attributes and a lot of information that may be best represented by arrays or sub-documents. But the challenge in our use case, if we want to mapping data from, let's say, Oracle to a modern database like MongoDB, then we are facing the challenge between a relational to document world conversion and the relational to document model. And TapData does have this key capability. We are specially designed to handle these complex use cases. So you can seamlessly convert tables one-to-one or many-to-one, because in MongoDB, it's really the best practice is to really design a denormalized data model, which consists of multiple tables into one single collection. So we have this capability allow you to replicate data from relational. Also, in the same time, too, you can combine them, merge them, or even consolidate them in however the way you want to. The final looking is a denormalized MongoDB collection. So having said this, explained this, our solution and the capabilities, next, I would like to show you a product demo and quickly, and you can see how you can do it with a sign up and using TapData within no time. And we will show two use cases. One is a simple replication from Oracle to Mongo. The other one would be a more complex, which is using multiple tables to merging a product tables into one product collection in MongoDB. All right, let me switch to gear to show you a product demo. All right.
Hi, welcome to TapData. In this video, we will explore how TapData facilitates seamless data synchronization from relational databases such as Oracle and SQL Server to MongoDB Atlas in real time. We will more focus on merging data from 4 tables in Oracle database into a unified collection in MongoDB Atlas. This is TapData Cloud Portal. Before we establish data replication pipelines, let's take a brief introduction to data replication, data transformation. First, let's navigate to the data replication section. A real-time data replication pipeline enables rapid achievement of real-time data synchronization between either same or heterogeneous data sources. We can copy the whole database or multiple tables from the source database to the target DB. The next one is data transformation section. TapData Cloud provides a wide range of processing nodes for complex data processing requirements. These nodes offer advanced capabilities such as data splitting, field addition or deletion, call external APIs via JavaScript, and merging of multiple tables from various data sources into target database, and much more. Okay, we need to set up connections with Oracle and MongoDB databases. Navigate to the connection section and click on Create button. Choose Oracle, and now we are on connection configuration page where we need to provide Oracle connection information. After filling in the required details, click on the test button to ensure everything is working fine. Okay, if the test connection is successful, then save the connection. Repeat the same process for MongoDB Atlas. Great. We have now created source and target database connections with TapData. Now let's proceed to create the data replication pipeline. Navigate to data replication section and click on create button. On the top left side of the page, you can see the database connections. Search Oracle and MongoDB Atlas. Click on Oracle DB and select the tables which we want to replicate. I want to replicate BM SQL item. Okay, now click on MongoDB Atlas. TapData Cloud also provide data validation feature. Click on Settings button and switch on data validation. There are three types of data sync: full and incremental sync, only full sync, and only incremental sync. I will choose full and incremental sync. This sync type replicates existing data into target and start automatically syncing incremental data from source to target database. Now save data pipeline and start it. We are now on monitoring page. Our data pipeline is running successfully. And on monitoring page, you can observe the task validation and the difference of total lines. This means if there are any difference between source and target database field values, then data pipeline will write the total number of rows here. And also data pipeline will check data consistency in source and target database. If there is any difference in total number of records between the source and target database, then you can see the total number of tables which are inconsistent in source and target DB. Now let's move to the MongoDB to see the results. Refresh the database. Here you can see BM SQL item is successfully written in MongoDB Atlas. And every insert, update, and delete event in source DB will populate in MongoDB Atlas in sub-second. Now let's create a materialized view and try to merge the tables from Oracle database to MongoDB Atlas. First, let's understand the structure of Oracle database. We have four tables: product, category, product supplier, and supplier info. Each product belongs to one category, and also each product can have multiple product supplier, and every product supplier have supplier information. So our objective is to consolidate all four tables into a wide table in MongoDB Atlas. The product table serve as a master table, while the other will be a slave table. So this is our target data model in MongoDB Atlas. Let's get started. Click on data transformation. Click on build materialized view. Select the source database, which is Oracle, and select the master table, which is product. So as I showed you in the beginning of this video, the target data model contains a category field with document type. So click on add field, embedded document, category. Okay, here we need to select again the source database, select the table, category, and select the association conditions, category ID, and category ID. Target data model also contains one another field, that is product supplier. So click on add field again and select embedded array, because each product can have multiple product suppliers. Okay, select the source Oracle, select the table product supplier, and select association keys, product ID and product ID, and also select update condition field. We need to choose primary keys. Okay, now every product supplier has the product supplier information. So click on add field and select embedded document, supplier info, select the table, Oracle, supplier info, okay, we have completed the configuration. Now click on write target and select MongoDB Atlas and write the table name or target data model name, which is product. So we can view the schema like this. Every product have category, supplier, product supplier, and product supplier have supplier info. Okay, now back to the data pipeline. Now you can see that a pipeline is successfully created, and master slave merge node will help to merge tables from source database to target MongoDB Atlas. Now click on save and run data pipeline. We are on monitoring page and our data pipeline is running successfully. Now let's move to the MongoDB Atlas to see the target data model, that is product. Refresh the databases. You can see the product data model is successfully written into MongoDB Atlas, and each product have category and product supplier, and product supplier have the supplier information. Okay. Now I will insert one record in Oracle database product table to see the real-time data synchronization. Let's move to the Oracle database. Insert one record where product ID is 9 and also add the product supplier. Okay, I have successfully added the record in product and product supplier. Now let's move to MongoDB Atlas. Refresh the target data model. Okay, now you can see here the new record is successfully added where product ID is 9 and the name of product is iPhone 15. Now I will update one record in Oracle database and we'll see whether it will populate in target data model or not. Okay. Here I will update the value from 1200 to 1800. Now first check the target data model price. You can see here the price is 1200 where product ID is 9. Now I will update to 800 and save it. Now back to Mongo Atlas. Refresh. Here you can see the price is successfully updated from 1200 to 800. I hope now you have clear understanding how we can use TapData to merge multiple tables into a unified target model in Mongo Atlas. Thank you so much for watching this video. Bye-bye.
All right, now let's back to our presentation. I hope that video demo was useful. TapData is, like I said, it's a CDC-based real-time data integration platform. It actually can do a lot more than just from relational database to MongoDB, of course. But today, our primary focus is on this topic. And I really encourage you guys to check out our cloud version, which is very easy to deploy, to use, to sign up and start using in no time once you have that environment ready. We also provide an enterprise, and in the near future, we'll provide a community edition as well. Let's take a quick review and compare to the previous two solutions we discussed today. We talk about in order to move data or make data available to new applications, we can build APIs, or we could use dual writes option involving Kafka, or we could use, now we have a third option with the TapData. And on the development effort, it's obvious we provide a no-code solution. And sometimes if you do want to do some complex handling, we allow you to using UDF or user-defined function to do some small-scale coding. We call it low code, but in general, you only need to drag and drop to perform this data movement compared to the other two. And for the impact to the existing application, we analyzed that for building APIs, you might have potential performance impact to the database. And for dual writes, it's more risky because you introduce potential code failures, bugs, and into the mission critical path. And for TapData solution, we only require to connect into your database. Now, compared to the query, we actually only look at your log files. So it's not in a lot of ways, it's not competing your database resources for the reads and writes. So we only take a very small percentage of the CPU cycle to really parse log files. So it has very low impact on your existing databases applications. And of course, TapData as a mature solution, a platform, a data integration platform comes with the real-time monitoring and alerts, etc. Make sure you can run this process ongoing continuously a month and years without with that peace of mind. So today, this will conclude our session today. And I really encourage you guys to start exploring what TapData can work for you. We have a freemium option in our TapData cloud. It's currently deployed in GCP. In the future, we will deploy on the AWS and other Microsoft cloud as well. And you can get 2 pipelines forever free on TapData cloud as long as you keep your account active and keep using it, the pipeline active. And you can also participate email survey for today's session. We will send you email to you. For those folks who didn't sign up with the email, you can contact my email address at tj@tapdata.io. And if you participate in our survey, you will receive a $50 Starbucks gift card. And that's it. Thank you very much for your time, and look forward to hearing back from you. Thank you.